Good morning, everyone. I'll be talking to you about the Equilibrium School Water Competition, which was actually conceptualized by Professor Cobus van Zyl, and he was my supervisor during my PhD. And so I've been helping him develop and market the school competition. So a bit of background. Started in 2003 when the South African Institute of Civil Engineers and Rand Water Centenary, and they were looking for a school water competition where schools could compete on different concepts about water and the urban water cycle. So Professor Cobus van Zyl introduced this as an exercise in his third year hydraulic engineering class and asked the students to come up with a competition, and so this idea was birthed. So the competition rules are quite simple. So the objective is to distribute 3 liters of water equally amongst 3 points. So there's 16 possible positions, so the adjudicator assigns 3 positions, and the teams are given a source of water and are asked to distribute this water using different pipe diameters. So you've got 3 pipe diameters that you can use to configure, just like a Lego. You put them together, and you switch on, you open a tap, and that water is distributed to 3 different points. So the winner, or the team that wins this competition, is the team with the least penalty points, and I'll get into that a bit later. So again, it started in 2003 and has been held on a national basis, so I invite all the schools here to apply for the competition. We do have a locally organized competition. The local winners are typically sent to Johannesburg through the SAICI Institute, and they compete at the national level, where different schools from different countries compete. So there's various applications to this. We typically use it as an educational tool, as a team building tool, for outreach purposes, as well as for teaching at the university. And generally, we have received some overwhelming positive feedback. So this is typically a picture of a team playing the equilibrium game. And in 2013, the Equinisweni Secondary School won the competition, and behind there is the SAICI team. So what is the main message that we try to bring about using this competition? So how does water get to your tap? I'm not sure if many of you actually know how water gets to your tap, but essentially this sort of competition teaches learners how that happens and how the civil engineer actually, what the civil engineer's responsibility is to ensure that water gets to your tap. And of course, it teaches a little bit about urban water cycle in a simple way, and the importance of looking after a water resource. Obviously, we try and market a career in civil engineering. We try and show how impactful a civil engineer is in society, and we try and encourage learners to do mathematics and physics, because this is essentially what allows a civil engineer to apply these methods. So this is the background layout of the competition. So you can see the lines across there are grid lines where the pipes are sort of put in place. But essentially, the background layout there is the urban water cycle, and this is what we try and teach the learners, and I'll go through it next. So we start off with a natural water resource, so you can see quite an active ecosystem there. And most cities in the world rely on rainfall as their primary source of fresh water. Okay, just like the city of Cape Town, I think, also does rely on rainfall for their fresh water. So it's important that we manage this resource well. Okay, so what does this entail? This really entails managing this very competing demand for water and ensuring that there's equitable access. As you can see, we use the ecosystem for different things, for entertainment, for our food, as well as infrastructure. So you can see we build a dam to store this water. And from that dam, we pump the water to a water treatment plant. Okay, again, the civil engineer is involved here. And what we really do here is to treat the water so that we improve the quality of water for different consumers. Now, once the water is treated, the civil engineer again designs a distribution network where the water is taken from the water treatment plant to different points of demand, one of which is yourselves as a consumer. So you can see there the water comes from the treatment plant, goes to a reservoir, and I'm sure you've seen a lot of these. They're elevated reservoirs as well as ground reservoirs, and they're distributed to our cities and our homes. And in our homes, we consume this water in different forms. We bath, we shower, we eat, we cook, we do all sorts of things, and we generate generally wastewater, which you can see in the green there. The wastewater is then conveyed to a sewer treatment plant. Again, the civil engineer is involved in trying to improve this quality of wastewater so that we put it back into our ecosystem, into the river. And the cycle goes on. But along that urban runoff, there's lots of activities that happen. Some industries are not responsible and throw all their wastewater back into the river. We have a lot of activities happening. There's litter that comes into the river. There's all sorts of things that happen between the upstream and downstream side of the river, which is important for the civil engineer to be able to understand so that we're able to improve this quality of water. And so we should be responsible as to what we do along that stream of water, because this water is the same water that we're going to consume. And ultimately, it goes back to our source, which is our dam, which we have to pump back to our water treatment, and the cycle goes on. So what the competition actually does is you're given 3 points anywhere along that grid, and you're asked, given a certain amount of water at the source, to distribute that water equally with different pipes. So you as your team, you discuss on how you're going to configure the system, put it together, and open the tap at the source, and the water will be distributed. And the winner, essentially, is the team that equally distributes a liter in each one of those points. So there's 24 pipes, 3,400 possible tank configurations, so that's different points at which you can allocate the tanks. 3 possible diameters, so you can either have no diameter, a big diameter, or a small diameter pipe. Then obviously that accounts to 3 to the power 24 possible networks for each tank configuration. So you can't actually have one solution. There is about over 282 billion possible solutions for each. So every competition is different. So this is an illustration of what the competition looks like when everybody's active. Again, we use this competition for various outreach. University Open Day to teach children about engineering, civil engineering, science, applied mathematics, applied science, that all comes into play. 100 Up is sort of an organization that deals with the disadvantaged schools. So we take this competition there, and the disadvantaged schools are trained how to use this. They get into the local competition, and some of them have actually gone all the way to the national competition and actually win the national competition. So if you want to get involved, again, you can contact SciC, and I can give you a contact for that. And various science camps and university conferences. Again, this is at the University of Cape Town during an open day where the competition is illustrated and various learners sort of play along with it. Again, different outreach activities that we see there, and this is at a conference in Adelaide where we also do it. So it can be for learners, for adults, for everybody. Everybody enjoys the game. It's quite simple to do and quite interactive. So you can join us using that website, equilibriumcompetition.net. You can apply there. You can look at the game. You can play it online. There's also a Facebook page with all the pictures and a little bit more information about the competition. Also, let us know what you're doing. If you're trying to have a team building competition, if you're trying to teach kids about water and conservation and fresh water and engineering and science and how all these things come together, please let us know via the website. And you can also purchase a set from Cobus Van Zyl. That's his email there. You can contact him. And we're always looking for partners and sponsors. So if schools want to have this as an integral part of their curriculum, you can also let us know. If LCA would like to have this as a competition as well, they can let us know, and we can all sort of work together. Thank you very much.